Hello everyone, my name is Jonathan Rule and I'm an Assistant Professor of Practice in Architecture from Taubman College of Architecture and Urban Planning, and I'm here today along with Shalonda Reeves, a Learning Experience Designer from the Center for Academic Innovation at the University of Michigan. We will be presenting work from an ongoing project funded through the XR Initiative grant at the university. The grant funds studies that explore how we can leverage emerging extended reality technologies to strengthen the quality of education, cultivate an interdisciplinary scholarly community of practice, and enhance a nationwide network for academic innovation. The project that we will be presenting here, Augmented Tectonics, focuses on the use of these technologies for the education of architecture students. Architecture has recently begun to fully embrace advances in extended reality technology. These readily available platforms are beginning to integrate themselves within the architecture and construction industries as a way to aid in project design, delivery, and execution. Over time, new pedagogical approaches for teaching and learning through immersive environments have been tested. Extended realities provide a significant step forward where students are able to move beyond their screens and embody designs through an immersive virtual environment, or an IVE. This setting allows for a greater understanding through heightened spatial awareness, as well as provides an alternative to visualize the complex array of layers that are included in the assemblage of a building. Within a pedagogical framework, the teaching of construction relies heavily on the presentation of assembly systems through precedent. Through this process, students are trained in interpreting, synthesizing, and making two-dimensional representations for the production of three-dimensional constructs. Within this process, the understanding of scale, physical constraints, and a grasp of the visual spatial reasoning and relationships are easily misinterpreted by an untrained individual. With this in mind, we began by asking two questions. First, can the visuospatial capabilities of extended realities afford students an alternative means to comprehend and synthesize content? And second, how should the immersive environment be designed from both an experience learning perspective as well as from an architecture perspective driven by content and space?
Because of VR's contextually rich environment and high fidelity approximation of practice being supported as providing students with transferable knowledge in the service of adaptive expertise, and again, keeping in mind that transferable knowledge is that which is experienced or acquired in one situation, but is used in the performance of a new and novel task in another situation, we thought that students designing and experiencing the act of making decisions in the VR environment really helped optimize and actualize the goals of the course and the purpose of the experience. In the diagram that you see there, the technology affordances such as immersion and simulated materials were able to help through the interface of the VR actualize our educational affordances, which is understanding the materials at scale and being able to make design decisions in a contextual environment where they received immediate feedback on how their design decisions impacted the greater understanding of the content. And so, therefore, our design and development not only created an engaging moment, but it also allowed students to understand how their knowledge worked in praxis.
Within the curricular core of the architecture program at Taubman College of Architecture and Urban Planning, undergraduate and graduate students without a background in architecture are required to take a construction course. The intent of this course is to present an overview of the materials, components, and systems of construction that reveal the links between the ideation, elaboration, and realization of architectural form. The course is structured through lectures and labs. Lectures are given weekly and provide an introduction and overview of a weekly construction topic, followed by a detailed look at case studies that exemplify those construction systems. The lab portion provides a series of exercises that take the subject matter from the lectures further through drawing, analysis, and discussion. The labs consist of weekly meetings where students work on a small drawing set, creating various orthographic representations and constructing a scaled mock-up of their wall sections at the end of the semester. It is the wall section mock-up that has proven to coalesce the students' understanding of the drawings and their meanings. It has somewhat produced what we call an aha moment in the course. The question became, how can we induce this moment of revelation of spatial and tectonic understanding from the beginning of the course to the end? In an initial study starting in 2019, the course was awarded funding through the Center for Research on Teaching and Learning at the University of Michigan to explore and develop a beta platform that leveraged game engine technology and virtual reality to create an immersive learning experience for students. The initial platform presented content on steel construction, using the Farnsworth House as a case study in addition to a generic structure that primarily used metal for its structure, framing, and cladding. The initial response by students to this immersive experience was that it was a lot of fun, but they didn't know what to do once they were within the virtual environment. In a second round of funding, the research was further advanced through the XR initiative at the university, which brought together an interdisciplinary team of architects, XR developers, and experienced learning experts to create a more robust experience and resolve the missed opportunities and downfalls of the initial build. This new build would also incorporate accessibility issues by providing both a virtual reality and desktop version, as well as the integration of multiplayer to allow students to congregate simultaneously within this virtual space. The presentation of content reconsidered the standalone cases and instead modeled the spatial experience after something we have all experienced in the flesh, a museum. Students begin their experience in the Drawing Center, which gives them an overview of architectural representation for construction based on the book Drawing for Architects by Julio McMurrow. In this central space, they are also given access to various material portals that coincide with the lecture topics given throughout the course. To further develop engagement and move from a passive viewing device to an interactive experience, the project developed different ways to access content. This includes animated displays, audio overlays, and challenges that would test the students' knowledge retainment after moving through the pavilions. In addition, the challenges replace the weekly multiple-choice quizzes students take as part of the metric for the overall course grade. The intention is that this method would put less emphasis on rote memorization and replace it with meaningful learning, which involves understanding how all the pieces of an entire concept fit together. The development process also required additional testing to gain a better understanding as to whether the design strategy of this learning experience was producing positive results. Through a series of pre- and post-trial surveys, as well as live demonstrations, the development team was able to collect qualitative data that either confirmed a positive response to this method of learning or showed where additional work needed to be done to ensure a more productive experience. The pre-trial survey focused mainly on the students' past experience with extended reality platforms, and in particular, virtual and augmented realities. It also intended to generate an understanding of the students' past use of digital learning tools and the perceived effectiveness of these platforms. The survey concluded showing that the majority of our students have had little to no experience with virtual or augmented realities, but the digital learning tools that they have used before, for example Kahoot, Flipgrid, Quizlet, have been helpful in improving their understanding of course content. In the post-trial survey, which includes responses from both VR and desktop experiences, concluded that the overall experience was helpful in developing a deeper understanding of the content conveyed in the lectures. In addition, a majority of the students felt that this program helped them improve their visuospatial understanding of 3D constructs and their 2D drawing counterparts. In addition to further understanding the impacts on students, the testing was able to illustrate key design flaws and unintended reactions by the students interacting in this virtual space. This included everything from navigation to audio overlay issues and the impulse for students to try to interact with anything and everything they could get their hands on. In addition to the feedback received through the surveys, students were asked to comment on their experience. A few, which you can see here, start to indicate that the current development is on the correct trajectory. As we continue to develop the remaining modules, these testing phases will be paramount to us getting it right and ensuring that the use of these immersive environments are not a passive learning experience, but a meaningful and engaging one. In conclusion, Augmented Tectonics interrogates and tests the affordance of using extended realities in a teaching and learning environment for students of architecture. While the focus of their research is on tectonic assemblages and the construction of the built environment, its underlying framework and the use of the technology has the possibility to transcend disciplines and subject matter. The study brings into question rote memorization by introducing a meaningful learning process whose foundation rests on experience-based learning strategies transmitted through a sensorially saturated spatial simulation. As stated by Jahani Palesma, the technological extensions of these senses have until now reinforced the primacy of vision, but the new technologies might also help the body. This experience of embodiment in architecture is paramount to understanding and developing a visuospatial understanding of the things we project. The accompanying image by Juan Navarro Alaveg echoes Palesma's sentiment by describing a progressive embodiment and vision of reality manifest through hand-eye coordination, materiality, and proximity. Architectural realities, both physical and digital, are an ever-evolving, intertwined component in our profession and education, with much more to be explored. As we continually adopt new modalities of embodiment within our discipline, we are confronted, and today more than ever under the current circumstances, with a blurred vision of their emerging potentials as we advance towards a clarity of possibilities at the interstices of hand, eye, tool, and material for the production and imagination of the physical and digital spaces. Shalanda and I would just like to thank you all for listening to this presentation. And if you have any comments or feedback for us, we'd appreciate it if you could email us at our emails that are on the screen. We look forward to hearing from you all, and thank you once again.